So we've got a circle here. This is my circle. It doesn't look like a perfect circle, but we can use our imaginations. And let's say it's got a radius of, let's say the radius of this circle is equal to 3 meters. My question, or the question we're going to answer in this video, is what is the area of this circle? What is the area? And remember, the area is just how much space this circle takes up on a surface, or on this computer screen that you're watching, or on this piece of paper. So it's literally, if you wanted a carpet, if this was a room, it's how much carpeting you would need to fill out this circular room. That's what the area is. That is what the area is. Now, I'm not going to prove it to you, and we'll do that later. But the area for a circle, it just takes on a fairly straightforward formula, and I want to just get you used to applying that formula. So the area of a circle is equal to pi. And remember, pi was that number that people figured out was the ratio between the circumference and the diameter of a circle. It's 3.14159, keeps going on and on and on. It's just a number, but it's a very magical number. Pi times the radius squared. Pi times the radius squared. In fact, another way of defining pi, you could even rewrite this right here, saying that the area over your radius squared. So this is your radius. So if you multiply the radius times itself, you could imagine that would be the area of a cube that's like that. That the ratio between the area of this entire circle and the ratio of this cube right here, that is or this square, I shouldn't say a cube. Cube would be if we went into a 3D. But the ratio of the area of this circle to this square right here is also equal to pi. That could be actually an alternate way of defining what pi is. And if you were to measure it very carefully using, there's thousands of methods you could do it, you would get 3.14159 and keep going on and on and on. But we're not going to delve too deeply into that. Maybe one day I'll make a whole playlist on pi. But we just have to know that the area is equal to pi r squared. So let's just apply the numbers here. So in our example, the area is equal to pi times 3 meters squared, which is equal to pi times 9 meters squared. Or the conventional way to write this is equal to 9 pi meters squared. And remember, 9 pi, the convention is just to leave it that way. But this is the same thing as 9 times 3.14159, which is probably going to be like 28 point something meters squared. Just remember, this is just some number, and it's not 9. It's actually closer to 28, because it's going to be 9 times 3.14159. But we just leave it like that. And that normally will be good enough for you to say, hey, that is my area. That's my area, 9 pi. Now let's go the other way. Let's say I have a circle like that. And let's say that the area is equal to 16 pi. What is the diameter? What is the diameter? What is the diameter of that circle going to be? Well, we know that area is equal to pi times the radius squared. So at least let's figure out the radius. So the area, 16 pi, is equal to pi times our radius squared. I'm just applying this formula. We're just going to keep applying this formula over and over again when we're dealing with area. So area, which we've been told is 16 pi, is equal to pi times radius squared. Now, if we divide both sides of this equation by pi, we get 16 is equal to r squared. And then you take the square root of both sides, and you get 4 is equal to r. I guess r could also be equal to -4, but we're dealing with distances here. You can't have a negative radius, or at least in the world we're living in right now. Just to keep things simple, we just want to keep our distances positive. So let's say that this has a radius of 4. Now, if the radius is 4, what is its diameter? Well, the diameter is always going to be 2 times the radius. So if this 4, we're going to have another 4 there. So the diameter is equal to 8. Now, let's do a slightly harder one that'll kind of compound some of the other things that we've learned in the past. So let's say that I have a circle here, and let's say that its circumference. Let's say its circumference. Let's say that its circumference is equal to 20 pi. and I want to know its area. I want to know its area. So the way you do all of these problems is just figure out everything you can given what they've given you, and then maybe you can work out the thing they're asking for. So if I know that the circumference is 20 pi, what do I know about its radius? Well, we saw in the last video that the circumference is equal to 2 pi times the radius. So if the circumference is equal to 20 pi, we could write that 20 pi is the circumference is equal to 2 pi times the radius. Now, if you divide both sides of this by pi, those cancel out. And then if you divide both sides by 2, this becomes a 1, and this becomes a 10. Or you get the radius is equal to 10, which makes sense, right? 2 pi times 10 is going to be equal to 20 pi. So we figured out our radius. Now, we know that the area is equal to pi r squared. And lucky for us, using the circumference, we were able to figure out the radius. Now, using the radius, we can figure out the area. So the area is going to be equal to pi times r squared. R is 10 times 10 squared, which is equal to pi times 100, or it's equal to 100 pi, just like that. So your circumference was 20 pi when you went around the circle, but your area of your circle is 100 pi. And if I gave you units, it would be 100 pi units squared. That is your area right there, 100 pi. Anyway, I think that's pretty good initial exposure to the area of a circle. I'll see you in the next video.